So in this video we can have to discuss about some actually circle geometry discussions and also some sort of the angle properties of the circle you should have to understand, and some actually quick reviews you should have to understand about the actually angle properties of the circle. And of course we already discussed about this lesson the time we are analyzing all these theorems, so just have to apply the quick reviews and also some examples and see how you can be able to tackle up different problems to do with the angle actually properties of a circle and some sort of the geometry. So let's start. So we have the first theorem that states that the perpendicular bisector to a chord is drawn from the center of the circle. Now let's say we have this as a circle. Let's say this is a circle. So according to the principle behind that theorem, it states that let's say this is a chord. Let's say this is a chord to a circle. Let's say this one is a chord. And that should be, let's say this is a chord AB. And let's say the circle is of a center, let's say given as O. So now, according to the principle behind that theorem, it says that a line that is being drawn from the center and touches the chord at a 90-degree. That's what it means there. So which means any line drawn from the center of the circle, actually it touches the chord at an angle of 90 degrees. That's what it means there. At the same point, it means the line has divided the chord into two equal parts. Let's say this is a point C. It means a line AC, it is the same as the line CD. That's what it means there in that way. And you should have to understand that this is a radius of a circle, and also this is the radius of the circle, so should be this. This is the radius of the circle, so you can be able to have the distance in which the chord is from the center of the circle, which is this distance. If we know the radius of the circle, and if we know the distance in which the chord is from the center, we can be able to know what is the length of the chord in that way. So take note of that. Of course, if you have the radius of the circle and the distance in which the chord is from the center, you can be able to have the length of the chord using Pythagoras theorem. So you can have, let's say, this distance and this length, actually in that radius you can be able to have the distance or the length of the chord using the same principle. So also see how you should be able to appreciate some questions on that actually theorems, but just have to know that a perpendicular bisector of a chord is drawn from the center of the circle. So take note of that. So, and what is another theorem we should have to understand? And another theorem is that of equal chords of a circle are equidistant from the center of the circle. So equal chords of a circle are equidistant from the center of the circle. Now what is that one? Let's say we have a circle. Let's say this is a circle in that way. Should be this. And now let's say we have two chords within the circle. Let's say we have that chord, and also we have, should be this chord as well. And say this is chord AB, and this is chord CD. Let's say the circle is of having the center, let's say given as the center O. So now if it happens that the chord AB and the chord CD are the same, then it means the distances in which each chord is from the center are the same. That's what it means there. Let's say in this case it means if the chords are the same, it means, let's say this is a distance d1, and let's say this is a distance d2. Now since the chords are of the same length, now you should have to understand this one as well. Since the chords are of the same length, it means a d1 is the same as the d2. Thus the equidistance from the center of the circle if the chords are of the same length. So take note of that. So from the fact that the chords are of the same length, it means their distances from the center of the circle are the same. So take note of that. What is another theorem you should have to understand? And we also have another theorem that states that angle subtended at the center by a chord or an arc is twice the angle subtended by the same arc at the circumference. So what is the principle behind that theorem? Let's say we have this as the circle. That should be that. Then let's say this is a chord. Let's say this is a chord. And assuming that the circle is of, let's say, a center given us, let's say this is the center O. It should be that. Let's say this is the center O. And let's say we have we have the angle that has been formed on the center of the circle by the this chord. Let's say this is the chord given as a chord AB. So you can see that the chord AB has formed an angle at the center given as, let's say this is angle X. Now let's say the same chord should have to form the angle on the circumference of the circle given this way. Let's say it should be this. So according to the principle behind, you should have to understand that in this case there is also an angle in which the chord has formed on the circumference of the circle. Let's say this is the, let's say given as the angle should be angle Y. According to the principle behind, since this is the center of the circle where the chord AB has formed an angle X, and the same chord has formed an angle on the circumference of the circle given as Y, according to the principle behind it, it states that the angle at the center is twice the angle at the circumference. So in this case we have it as X is equal to Y. That's what it means. So if we have the angle at the center, then the angle at the circumference is given as Y is equal to X over 2. And we have the angle on the circumference, let's say in that way, the angle at the center is given as that. So take note of that, in the sense that let's say if the angle at the center is given as 50 degrees, it means the angle on the circumference will be given as the half of that one, which is given 25 degrees. Of course, we're going to see some of the examples to do with this actually a theorem, but just have to understand that one up to. So no matter what, you have to understand it the same way. So take note of that. Even if we can have this orientation, principle remains the same. Let's say we have it in this nature now. If we can have it in this way, let's say this is the case. Mind you, this theorem only works if we have the center of the circle. Let's say if we have that case, Stromo, this is angle the circumference formed from the same chord. And let's say if we can have it in this way as well. Let's say if we can have it in this way. So now Stromo, this is the angle at the center and this is the angle at the circumference, much as they are formed from the same chord. which is the chord AB. So take note of that. So what is another theorem you should have to understand up to? And we have with that states that the angle on a semicircle is actually a right angle. It is a right angle. So what is the principle behind that theorem? Let's say this is a circle, and let's say with a center given as, let's say, a center O. And assuming that we have a diameter, mind you, a diameter is the line that is drawn from one side of the circle to the other side and happens to pass through the center. Let's say this is the diameter AB. So should be that. And by the way, the diameter AB can also be said to be chord, only that since it passes through the center, it is said to be diameter. So what is the angle in which the diameter has to form on the circumference of the circle? Let's say this is the case. You have to understand that since the diameter has formed an angle on the circumference of the circle, that angle formed is said to be a 90-degree angle. So this is only happens if the chord is a diameter and the angle in which it forms on the circumference of the circle is given as the 90 degrees. That's the principle behind that theorem. That states that the angle on the semicircle, actually the angle on the semicircle, on this point is said to be the 90-degree angle. So only if the line passes through the center, which is a diameter, the angle it forms on the circumference of the circle, it is given as the 90-degree angle. So that's the principle behind that one. And we also have another theorem. What is that one? That one states that angles subtended by the same chord or arc on the circumference of the circle are the same or are equal. What is the principle behind that one? Let's say this is a circle with, let's say, a center O. So should be that. Can be a circle with a center or without the center. So this theorem does not really matter whether the circle is having the center or not, but just have to know that. Let's say this is the circle with the center O. Then let's say this is a chord. Let's call it, let's say, a chord A, B. Now, let's say this is the angle in which the chord has to form on the circumference of the circle, let's say in this case. So in that case, the angle, let's say, is given as the angle X. Let's say we should also have another angle in which the chord has to form on the circumference of the circle, let's say in this niche. Let's say this is the case. Now I should have it as, let's say, angle Y. Now since these angles are formed from the same chord, now according to the principle behind the theorem, it states that the angles subtended by the same chord or the arc on the circumference of the circle are the same. It means angle X is the same as the angle Y, since the angles are formed from the same chord, which is the chord AB. Even if you can have, let's say, without this chord AB, you can still more depict that. Let's say if you can have this case, you can still more depict that. In this case, these angles are still more being formed from actually this chord. Even if you can have it without that one, it is the same as well. You can know that if I tend to connect the 2 points, I'll have the chord in which these angles are being based from. So take note of that. And even this angle, let's say this angle and this angle are also the same, because they are formed from the same chord as well. So it should be that. That's the principle behind that theorem. What else you should have to understand about the angle properties of the circle and the concept behind the circle geometry? How should you have that? Now we have another theorems that are based on the actually acyclic quadrilaterals. So we have the theorem that states that the opposite angles in a cyclic quadrilateral are supplementary. So what is that one? Let's say we have this as the circle. It can be like that, of course. And let's say the circle is of a center, let's say O. It can be a circle with a center, let's say O. And let's say we have a quadrilateral inside the circle. Any four-sided figure is said to be a quadrilateral. Let's say this is the case. So according to the principle behind that theorem, it states that, let's say this is angle X, this is angle Y, this is angle U, and this is angle V. Now, the opposite internal angles of this actually a cyclic quadrilateral are supplementary in the sense that angle X plus angle V is equal to 180 degrees, and angle Y plus angle U is equal to 180 degrees. That's what it means there. Of course, at the end of the day, the summation of the angles of any four-sided figure is given as 360 degrees. That much you have to understand. So that's the principle behind that theorem. And what else you should have to understand about the angle property of the circle, and basically for the cyclic quadrilaterals. And of course, we also have another theorem that says that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle of the same cyclic quadrilateral. So what is the principle behind that theorem? Let's say this is a circle. And say we are having the cyclic quadrilateral. That should be this. And say we are having the cyclic quadrilateral within the circle. Can be like that. Much as it is a four-sided figure, then we are safe. Now let's say this is, now let's think of having projected the angles. That should be this. Let's think of having this. Let's think of having this. And also let's think of having this as well. We should have to project the lines as you can see it here. Let's say those are the cases you have to understand. And let's say we have, this is angle A, this is angle B, this is angle C, and this is angle D. And now let's say this is angle, let's say X, and let's say this is angle Y, and say this is angle M, and let's say this is angle U, and also let's say this is angle V. Just have to mention the few. So now according to the principle behind that theorem, it states that in this case this is an external angle of a cyclic, the angle which is outside the cyclic quadrilateral. So in this case, what is the angle, what is the interior angle which is opposite to the interior angle of this angle? So first you should have to understand that this angle M is the same as the angle A. And this angle y is the same as the angle b, and the angle x, now it is the same as the angle d. In the angle v, it is the same as the angle c. So that's the principle behind that actually a theorem. That states that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So that's the principle behind it. So now let's have to go through now the angle properties of a circle and something to do with the tangents. So what would be that one? And we have a theorem that states that the tangent to a circle is perpendicular to the radius at the point of contact. So what is that one? Let's say if we have a circle. Let's say this is a typical circle. That should be that. And let's say we have a tangent to a circle. Let's say given as this. Let's say that's the tangent. And say it is given as the tangent AB. And let's say the point in which the tangent touches the circle, it is given as a point C. And let's say this is the center of the circle given as the center O. So now, any line drawn from the center of the circle, let's say the radius drawn from the center of the circle to where the tangent touches the circle. So the angle in which the radius formed with a tangent is said to be a 90-degree angle. So that's the principle behind that one. So now, whichever the case, even if the tangent was on this side, so should be that. But much as there is a line drawn from the center of the circle to that tangent, it means the angle that will be formed will be given as the lateral angle, that is the 90-degree. So that's the principle behind that theorem in that way. And we also have another theorem that states that the tangents from an external point drawn to the same circle, so should be are equal in length. Let's say this is a circle. Now can be that. And let's say, of course, let's say the circle is of point O. And assuming that we have a point, let's say this is a point P outside the circle. Now let's think of having the tangents being drawn. Now should be this now. We should have that point. Let's say should be this side. Let's say this is a point P. In this case, let's think of having the chords being drawn. Actually, should be the tangents being drawn from the same point, which is outside the circle, and to the same circle in this way. Let's say this is a point S and this is the point Q. Now, according to the principle behind, it is this that the tangent PS is the same as the tangent PQ, since they are drawn from the same external point and are being tangents to the same circle. So that's the principle behind. So try to understand it in that case on that way. And we also have another theorem. What is that one? Now the theorem states that if a straight line touches a circle and from the point of a contact a chord is drawn, the angle which the chord makes with a tangent is equal to the angle subtended by the chord in the ordinate segment. So what is the principle behind actually this theorem? So take note and understand this one. Now let's say we have this circle, and we have a chord given as this. It should be a tangent rather. Let's say this is the tangent to that circle, given as that. Let's say this is a tangent AB in the same way. So now let me just have to eliminate this one for you to understand. So now this is a tangent to a secotangent AB. And let's say this is a point C in which the tangent touches the circle. So let's think of having a chord and happens to touch also the same tangent at a point C. So what is the angle in which the chord has formed with a tangent? This is the angle, let's say, given as should be x. Now let's think of having the angle formed with the scaphoid of the circle in which the chord has to form. So in that case, we'll have that as this. So now you have to understand that this is the tangent line, and we have a chord being drawn onto the tangent, and the angle in which this chord forms with respect to the tangent is given as the x. Now what is the angle in which the chord has formed in the scaphoid of the circle? We have this one as, let's say, y. According to the principle behind, angle x is the same as the angle y. And likewise, if we can have also this angle, let's say this is the angle m. So this is the angle in which this chord forms with a tangent line. And the same chord formed an angle, let's say, on the scaphoid of the circle given as the n. Then angle m is the same as the angle n. So take note of that. And of course, next you should have to discuss about how we can be able to draw the tangents to the circle part. Next video you should have to discuss about some of the problems we have to go through on these theorems we have recently discussed. So that will be for the another video I'll have to bring up to you. But you have to understand about all those theorems we have recently discussed, because they are the ones that you should have to understand, and for the sake of your exams, that is MSc, and you'll be able to capture those things. So now, thank you.